So now we come to the part 2 of 3 of this video for this week on the hazard identification. And this part 2 we will emphasize only on the hazards and operability studies, the HAZOP study. The HAZOP process is based on the principle that a team approach to hazard analysis will be more efficient and give us more to identify more problems compared to individual working separately and combine their results together. So HAZOP analysis is always done in a team brainstorming. And so this team has to make up from different background and expertise, such as you have process engineer in there. You may want to involve the operator as well and the line supervisor, for example, or even you want to get someone from outside of the process to give you a different perspective or different idea. Okay, so the expertise is brought together during HAZOP sessions through a collective brainstorming that stimulate creativity and new ideas through a review process under considerations is made. So it's a structural critical examinations of the plant or processes being taken care by a team. Okay, so to do HAZOPs, we are going to give you certain rules and regulations, such as there are certain standard guideworks that you need to apply. And it's a formal procedures to identify hazards in a chemical process facility. So in order for us to run HAZOP, there are few informations that we need in hand before we start any HAZOP analysis. So the first one will be the process flow diagram, the PDFs. We need them. Then with the PDF will tell us what are the process, what are the first processes, and go to the second and go to the third. And then we want the individual process and instrumentations diagram, the PNID, that will tell us all the individual control systems or feedback systems in the process, in the overall processes. Then we also want to have the equipment specification, the material of constructions of your vessels and pipings, etc. And of course, the last one but not the least is the material and energy balance of the entire processor. So these are the 5 things that is required before we can conduct a HAZOP analysis. So we need to have all this data before we start. So once we have all this, then what we will do is we break it into what we call a process flow sheet. And in these process flow sheets, we would then break the system into different process units. So this is what we call a study note selection. So meaning if we want to study, because there is no way that we can one-shot study every processes. So we have to select from point A to point B. We are only focused in this. That's what we say study note selection. And in the study note selections, then we look at the process parameter that we want to study. So give you an example. If we have a reactor, for example, so you want to select the reactor flow rate. Then the process parameter here, we focus on the flow itself. And once we have the parameter, then we put in the guides words, like given back to the same example. So we have the flow rate of the reactor, so the input and the output flow rate. So what happens if the input flow rate is too high? What happens if the output flow rate is too high? And what is the consequences of this high input of flow rate or high output of flow rate? Or what happens when it is too low? And what happens if there's no flow? So these are the guide words that will be given for us to run analysis for each parameter. Then the next one is we look at what are the possible causes to cause high flow rate or low flow rate or no flow rate. And then we look at the consequences of these causes. If let's say we have high flow rate, what will happen next? If let's say low flow rate, what is the consequences? Then look at all this data. we then recommend what are the actions need to be implemented. And then we repeat for all the guide words. So you start with too high. Then once you have done with all the too high flow rate, then you repeat with low flow rate. What happens when the flow rate is too low? And then we start again. And then what happens if there's no flow rate? Or what happens if, let's say, there's another guide was given as reverse flow rate? What happens if there's a reverse or back flow, etc.? So once you are done with all the guide words, the next thing is you want to refer back to the process parameter. So now we have studied the reactor flow rate. What about the next one? We study the reactor temperature if you have an exothermic reaction. Then you start the whole process. That is why I say HAZOP is a complicated or comprehensive analysis for identifying hazards in the process, because you basically look through every single process in there. So these are the key process parameters that we are going to look at. It's like flow, as I given you the example earlier. Then you can look at temperature. The next one, you can look at pressure. You can look at the water level or the chemical levels in there. If let's say you have separators, then you want to look at the sediments, you want to look at the filters, or you want to, if you have reactions, you want to look at the compositions, the conversion. Then you want to look at the mixture, etc. So these are the basic guide words that we can use to study. These are some basic parameters for us to study. And this page shows us the guide words that we can use for every single parameter. Not all are being used. Like for example, when we talk about flow rate, we can't say as well as flow rate, because there's no way that we can go for as well as. But you can have no flow. We can have higher flow. We can have less flow. Can we have part of the flow? That will be part of the less flow. So there is no, then in flow rate, in terms of flow rate, we can't use part of, we can't use as well as, but we can use reverse flow. And if we have, for example, chemical A coming in, but instead of chemical A coming in, chemical B came in, what happens? Other than, or sooner than, or later than, if you have a timing for each flow to come in, what happened if the timing go off? It came in earlier than what is expected, or it came in later than what is expected. Okay, so these are the guide words that help us to use in HAZOP analysis, but not all the guide words can be applied in every scenario. So this stage tells us the guide words that we can use for process lines, meaning the processes, the pipelines. So we can look at flow rate, and we can use the guide words of no flow, higher, lower, sometimes as well as a part of reverse, etc. And then you can look at temperature, but there's no way that you can say no temperature, because there is always a temperature there. So this gives you an idea of what keywords or what guide words to use for each process parameter. This is an example for process line. And this is an example for process vessel. So meaning if you have a vessel, you have a reactor, you have a distillation column, you have a separator, or you have a mixer. So these are the parameters you can look at, and these are the guide words that you can use for those parameters. So in HAZOPs, we use assumptions because this technique assumes a good level of general management's competence, and we assumes a lot. Okay, but if let's say these assumptions are not valid, then this HAZOP has very little value. So even when we want to make assumptions in HAZOP, it has to be practical. Or the words that I like to use here is use common sense. So there's no use identifying hazard if nothing is to be done to manage or control of that consequence risk. So for example, you can run a HAZOP analysis of burst tire. So if the tire come in burst, there's a hole in there. And can you manage it? Well, you just have to change it. So at certain situations, you don't need HAZOP. Okay? So if it's little use installing trips and alarm if they are going to badly maintain. So meaning in HAZOP, we want to avoid just putting in alarms because from the previous experience that I have, students love to put in alarms as part of their HAZOP analysis, or it's fresh engineer. They just like to put in alarm. So imagine like you flow rate, high flow rate, you have alarm, low flow rate, you have alarm, and you have 500 pipes lying in the production. So you have alarm flow high, alarm flow low, alarm flow input, alarm flow reverse, and basically you make an orchestra out of the whole plant. So if you just put in alarms and trips, it's not going to be beneficial if you're not going to maintain them. So to do HAZOPs, once you have that actions, make sure you know how to maintain the action. It's not a one-time thing. These slides give you an example or an overview of how a HAZOP forms look like. So I'm going to draw a little bit here. So for us to start, so of course you want to find out what is your study notes first. So for example, I want to study cooling line, cooling in line. In your process, perhaps reactor, for example. And so cooling in line, the process parameter, perhaps your cooling water flow rate. You can do flow rate, or you can do temperature. And what else? You can think about it, and then you see what you want to do. So for flow rate itself, there's guide word, there's no flow. What happened? There's no flow. So possible cause for no flow may be cooling tower failure, the incoming cooling tower malfunction, or it can be pump malfunction. Okay, and it could be also what else can cause no cooling water flow rates. You can think about it, maybe the piping block or burst before that. So you have to be creative to think of what can cause the flow rates not coming in and the consequences of all this. So you can look at the consequences of no cooling water, or you can look at the consequences of each of this failure. Okay, there are two ways of looking at consequences. One is the no water flow rates of your cooling water into your reactor. Then what do you need to take? What actions you want to take? So consequences of no cooling water, then your reactor can go, reactor's temperature increase and potential burst, potential runaway system, because you can cool down the system. And what are the actions that is needed? So you may want to first, you may want to give a relief system. So when you have a high pressure vessels, because of temperature go up, there's a potential runaway, at least you have a release system to guide, to safeguard it. And you may also want to have a emergency shutdown system. Shutdown to prevent further explosions or further pumping up of your reactions. So perhaps you may want to look at shutdown valve for incoming chemicals, so that you complete whatever reactions so that you contain in your reactor. So you have this chemical in here, so you do not want to have anything coming in here, so that whatever here get to react. So you want it to have complete reaction, etc. So these are the things that we can do as a simple HAZOP analysis. So as you can see, just by looking at one parameter, one flow rate here, with no flow rate as a guide word, and we already have a few possible causes in here. So that's a few possible causes, and then also we have a few potential consequences. So, and there are several actions that can be taken. So then with this one, you want to assign it to who is taking care, so assign to who or which department. And so when are they supposed to take actions, and the number of actions being taken, is that completed, etc. So this shows us a HAZOP form. And an easy HAZOP analysis can go up to several pages, from 20 to 100 or even hundreds of pages, because you can see this is only one guide words. We haven't even go to high flow rate, what will happen? Low flow rate, what will happen? Or instead of cooling water coming in, what about if, let's say, it comes in as heated water? So meaning the flow rates go off and something else came in. So then we look at temperature. So what happens if the cooling water came in, but there is a low temperature? It's supposed to be at 20 degrees Celsius, but it came in as 15 degrees Celsius. Or what if it comes in at 40 degrees Celsius? What will happen? Or if come in as at the boiling point, what will happen? That's temperature. And then you make a look at, if let's say some share line that share between cooling water and steam. What happens instead of cooling water come in, and as well as maybe steam that came in? So then you can see just by one process parameter on the cooling in line, there are so many things to study. So other than that, you have, this is only a cooling line. We still have other things like the liquid level, for example, the pressure, for example, in your reactor. But this is only reactor. What about after reactor? You have separation processes. And after the separation process, you have distillation column or purification process, etc. So you can see this will lead you to a lot of pages next. So since we already talked about a HAZOP's analysis, that I show you a quick one. So let's take a look at this example, the HAZOP example here. The reaction system shows below is exothermic, and the cooling system is provided to remove excess energy of reactions. So in the event of cooling function is lost, the temperature of the reactor will increase, and this will lead to an increased reaction rate, leads to additional energy release. The result could be a runaway reactions with pressure exceeding the bursting pressure of the vessels. That's bad. So the key functions here, the keywords is that when the cooling function, so you can see the cooling line here. Let me highlight them for you. Okay, so you have a cooling water in. You have your cooling water in. So this is your cooling system that go in, and come out here. So cooling water out. So our study notes here is obvious. So you want to study the cooling water in to cooling water out. Okay, so when this cooling function is lost, first your temperature go up, your reaction rates will go up because of the temperature go up, and so your energy in basically increase because of the exothermic reaction. Okay, then with all this increase, you have your pressure increase. And if, let's say, this continue to go up, up, you might have a rupture a rupture vessel. So now we ask you to use HAZOP to improve the safety of the process. So the study note is the cooling coil, which is here. So your study note, you want to study from A. Okay, let me write it A to be here, your study notes. And you want to study two things. You want to study the temperature and you want to study the flow rate. Just now I already gave you an example of the flow rate, what happens when there's no flow. And then you study that one. And here we also ask you to study an additional things, which is the stirrer. So that is the second study note. Okay, so second study note, this is the first one. Let me use a different color. Second study note is this one. Your study notes is your stirrer. Stirrers, there's only one thing, your RPM. How fast will it stir? Okay, so this is an homework. Gather in group of 5, you find your own friends, and you start to have your online class, online discussions to have a brainstorming on the safety review by using HAZOP for this example. So it's easy to use Google Spreadsheet in this case. You just put in the column like what I showed you earlier. So you have your study notes, and then you have your parameters, you have your guide works, and then what could go wrong, the potential cause and the potential consequences, and what actions do you want to take. So then you want to work on the flow rate, you want to work on the temperatures, and you want to work on stirrer. And so submit by this Friday. Put in the names of all 5 of you in the group so that I'm thinking of giving you an assignment link to submit, but as I speak right now, perhaps I will give you the Google spreadsheet for you to work on so that every 5 of you will give me a results of your discussion. Okay, so either by Google spreadsheet, you share with me your link, or I give you an assignment submissions link in time so that you can submit your spreadsheet. Okay, I suggest you use put this in your Excel spreadsheet or Google spreadsheet, because that will help you to reorganize when you realize there's something that you make a mistake here and there. You can straight away swap it, just copy and paste. So submit it and discuss among yourself. Normally when we have face-to-face classes, I will do this as a classwork. So I give you all Manila card or the mahjong paper, then you'll just do your magic. But right now we can't do that. So I want you to submit by this Friday as an attendance record. So remember to put in your friend's name, 5 of you in a group, not more than 5, maximum 5. You can have 2 or 3, but at least have 2 because it must be a group work. Okay, so with that, part 2 is completed, and part 3 will focus more on safety review and formal and informal safety review. Thank you. See ya.